Hello, everybody, and welcome to another Microsoft Reactor live stream. Back today with a Learn Go with Liam session, and this is episode number 2 of a 4-part series. So it's great to have you here. I'm going to share my screen, and I think we can just get into the slides. Cool. So hopefully you can see me, or see my slides rather. So yes, welcome. It's great to have you here, and it is called Let's Go. Please do put in the chat where you're from, and I will get back to you. So at the moment, currently my setup is taking over both my screens, but afterwards, when we're done in between the slides and the coding, I will pick up any questions you have. I will say hello to you. So a massive thanks for joining today. So as always, a code of conduct. Please take a second to read this. It's really important that we all follow this. So it's really simple. Please be kind. Please be respectful. The chat is open, so ask great questions. Now, I don't want to start off on a solemn note, but I do want to mention this. I want to acknowledge this. So in the tech industry, over the past the past week or two, my timeline on Twitter, on Facebook, on all my social media has been covered with all of these tech layoffs. And that is really, really sad to see. Everybody's affected. It's really not very nice. So what we've got at Microsoft is some great upskilling programs that I'd just like to share with you. So this is a blog post, which is on one of our community pages. You can access this via the link above, which is aka.ms/get-connected-now. And what you do here is you can just run through some of these steps. So explore career paths with Microsoft and other sort of tech companies. You can join the the dedicated Microsoft Learn talent organization. So you can grab us and sort of have career chats, and you can see where you can sort of upskill yourself on Microsoft Learn. We have got, so you can get prepared, so you can prepare for interviews and other tech related conversations that you'll be having within the industry. And then of course you can help build out your LinkedIn profile, and we'll help you do that as well. You know, this is really sad to see. So of course we want to help you as best as we can. So before I get started with the episode today, I just wanted to run through that one with you. So what else we got? We have the agenda. So as always, I have an agenda, and that's what I was missing. I was missing my clicker. So we have an agenda like all of my streams. So we're going to go through a little bit about me, who I am, what I do, and where I came from. We're going to look at a cloud skills challenge. That is right, people. I have created a cloud skills challenge for this series. Finally, I forgot to do it for my first episode, but I did say I would have it for today, and I do. We are going to do a quick recap on what we went through. I guess it was 3 weeks ago. My goodness, yeah, 3 weeks ago. Time goes quickly, right? Going to do a quick recap on what we went through, because there was a huge agenda. We're going to look at imports. So we're going to get into the thick of today's episode. We're going to look at some imports and how you import in Go. We're going to look at some functions and, you know, the kind of functions that are supported within Go, within the Go ecosystem itself. And then we're going to look at some testing and how you should test versus, you know, how you write a test and the different examples that I can show you with different imports. And then we're going to jump into some code. The fun bit, because I realized in the last episode after I watched it back, it was about 50 minutes of me speaking and about 10 minutes of me creating a Hello World program. So what we're going to do is we're going to go through some code examples for each of the functions. I've got a code example in Go Playground online, which again, I have links I can share with you as well. And then I'm going to look at some testing locally. So I've created a sort of a quick scenario locally where we'll do a table test, we'll do a regular test, we'll do some benchmarking, so I can show you the different kind of ways that we can do that locally. And then I'm going to write a HTTP web server if we have time, because again, that is what I said I was going to do in the description, and I don't want to leave you shortchanged. So I will be looking at how you can create a web server in Go. Pretty fun, because it's a great way to sort of get started with Go and understand HTTP protocols and how you can start using routing. So if you're familiar with Node Express or Node.js, then this will be a great sort of advancement on from that. It's very similar in the way that it works with routing, but we'll get into that a little bit later. So who am I? What do I do? And where do I come from? So my name is Liam Hampton, and I'm a Microsoft Regional Cloud Advocate based out of the Microsoft Reactor here in London in the UK. So if you're not joining from the UK, it is nice to have you. And I just got a ping in my ear for notifications, so I will turn that off in a moment. So what does a cloud advocate do? Well, a cloud advocate helps teach you and helps upskill the community in different areas, in different sort of aspects of technology. So I specialize in Go and DevOps. You may have seen some streams before that I've done, or some sort of talks that I've presented. And what we do is we'll go around, we'll do conference talks, we will help you with your career, we'll help with different aspects and guide you in the right direction for your career and how you can personally upskill and get better at what you do. I'm an Auth0 ambassador, which means I think about security first. So always switched on, always thinking about the principle of least privilege and sort of the least access rights for you, and sort of helping teams work more efficiently with security top of mind. Because as an advocate, I speak to a lot of developers, and the amount of times people tell me, you know, they haven't thought about security, or it's fine, it doesn't matter, or they haven't updated their packages or something, you know, you want to start thinking about that. So I became an Auth0 ambassador. I am a Go and Node.js software engineer. So background, so prior to working at Microsoft, I actually worked at another big tech company, IBM, and I was a software engineer there. And I was creating and maintaining open source projects and creating CLIs, etc. So it's really good fun. I got a great backing in software engineering, and I just loved advocacy so much. I wanted to talk about how I code and what I code. I'm an IT enthusiast, and I love to travel. And there's a picture of me in Dubai and a picture of me presenting here in the London Microsoft Reactor. So enough of me. Let's get on to some learning goals. With all of my streams, I always have learning goals, so you can tell whether this stream is for you or if it is not. And today I want you to understand the fundamental basic semantics of Go programming. So that is to understand imports, functions, and testings, because those are like the three pillars that hold up a great architecture and a great bit of software. You know, without testing, you're sort of you're playing with fire. Without functions, they're pretty central to most programming languages. And imports, of course, how do you import standard libraries and third-party libraries when you want to code? So some great pillars for you to sort of run off. And secondly, how to stand up a simple web server in Go, because it is one of the most commonly used programs that I see at the moment is a HTTP web server, and sort of how it is used as middleware and sort of part of the MERN stack. So I think it's like Mongo Express, but instead of having Node Express, you'd have Go and maybe like a React front end or something. So it's kind of in the middle there, which is pretty cool. But we can dig into that later on if you have any questions. So of course, you can do this too. With everything I do, I try and make everything as free. So of course, we're not actually going to be deploying anything to Azure today, but in future, we may well do just that. So if you want to grab a trial account, or you want to sign up to Azure and get some free credits, if you're a student, go to aka.ms/A4S. And if you're a professional, or rather anybody who is not a student, then go to azure.microsoft.com/free. You can grab yourself an account with some trial credits, and you can get into all the services. I think it's like $200 for 30 days. So you can go through, spin up a whole bunch of services, and have some good fun with that one. So what's going on with the series that we're running? So last week, we ran the fundamentals of Go. No, not last week, last session. Sorry, 3 weeks ago, the fundamentals of Go. And today we're going to be going a little bit deeper into the imports, functions, and web server. And testing. Almost forgot testing. Obviously, you can see on there episode 3 and 4, and they will be coming, I think, in the 30th of November, so the end of this month, and then 2 weeks after that as well. So this was the only 3-week break, I believe. I apologize, but I'm back. So, Cloud Skills Challenge time. Please scan this QR code and have a little look at the Cloud Skills Challenge that I have created and put together. So this is a couple of modules on Microsoft Learn, which will help you get into Go and sort of help explain from A to Z, like a real quick overview, kind of what I'm doing with this series, but more of a reading. And you can do it at your own time, in your own schedule, and you don't have to be pressured to do anything at all. There's only 8 modules in there, I believe. It says 5 hours, but it's really loose on that timing, so I wouldn't take that as anything to go by. I'm sure you can do it quicker. Obviously, if you read faster, it's just an average. So please do check that out. You can go to either scan the QR code, which is on the screen, or you can go to aka.ms/learn go with Liam CSC, which stands for Cloud Skills Challenge, if you hadn't already guessed. So let's have a little recap. And I'm going to leave this QR code on screen for like a slide or two. So if you missed that one, it's still there. So let's have a look at the recap on what we did in the last episode. And this was the agenda, which was pretty beefy, and I apologize. So we have history of Go. We looked at the design objectives of Go. You know, What was its purpose and why did they want to create Go? We looked at some of the key features of the language. We looked at Go versus different languages. I think I chose C and Python and one other, maybe Java, I can't remember, which is really good because it helps you understand in what scenario you would use Go versus a different language, because every language has a pros, has its cons, and it's good for its different purposes. You know, you wouldn't necessarily maybe use Go to spin up a front end website. You know, you wouldn't use it. I mean, you can use templating libraries to do exactly that, but I probably wouldn't because it's not designed for it. Then we looked at where it is used: Kubernetes, Docker, CLI heavy, cloud native tooling. You know, part of the CNCF, I think it was an absurd number of projects in the CNCF, which is Cloud Native Computing Foundation, I believe that stands for, is actually built with Go. So that's a really cool one. So of course, if you missed this episode, please do go back. I will drop a link in the chat for the previous episode, which is on YouTube and recorded. What else? We looked at my journey. How did I get into Go? I explained how I created a CLI whilst I was working at IBM, and it was a driver behind a VS Code plugin, which was pretty cool. We looked at package management, and we're going to dig a little bit deeper as well with that one today. We looked at numbers, so statistics. That was almost caught me out then. Statistics on Go in the community. So I looked at some Stack Overflow comparisons with that and sort of where it stands in the market, which is pretty awesome. And then I showed you a video of how you can install Go on your machine. And I did a recording on the day, so it's the most up-to-date version and the most up-to-date way you can do that one. And then I, of course, spent 10 minutes, very loosely at the end, creating a Hello World program and answering some questions. So if you want to catch that, please do check it out on YouTube. Again, I'll post a link in the chat. And of course, now's your last chance to scan that QR code because it's about to disappear. Let's get into the beef of today's episode. Let's get into it. So let's look at imports. Okay, imports is a really, really important part of a programming language because it allows you to bring in different packages from within the standard library, and it also allows you to bring in third-party libraries. So we established in the last episode that Go is really, really well connected with GitHub. So all the documentation that you write with your GitHub profile, it's not your profile, your module or your application that you publish, will then go to pkg.dev, I think it is, or go.pkg or something like that. It's really, really tightly coupled between the actual documentation site and GitHub itself. So imports are really, really important because it kind of goes through all of these different proxies to try and figure out sort of where it's pulling it in from. Is it getting the right version, etc., using Go modules? And they look a little bit like this. So this is an example of a standard library import. We've got net, we've got math, we've got FMT. And FMT stands for format, math is for maths, and net is networking. So we look at this little program on the right-hand side. We have got package main, import math /rand. Okay, so rand is part of the math package. So it's like a function within math. And what I'm going to do, or what this function is doing, is it's iterating over a loop, I think 10 times, and it's going to print out some random numbers. But the only thing I really care about this function, what I want to take away from this is rand.intn. So rand, we've imported it at the very top with that one single line, and we're calling the rand package at the bottom, just like you would with any other program. That's how you can use an import. And you just reference it using dot notation inside a function if you want to get to a method or a function within that package. Like we've imported math, we've imported the rand part, and then we're going to call rand and then a function within there. And of course, we've got third-party imports. So some really sort of popular third-party imports, ones that I especially use as well, is Gorilla Mux and GoFiber. Coincidentally, they do exactly the same thing. They are just additions to the net HTTP package, which is all about routing, and it is really, really similar to Go Express. My goodness, I'm getting confused there. Node Express with routing. So same principle, but they're third-party libraries. How do you install them? Well, you can't simply just put them at the top of your package and expect it to just grab it from GitHub. You wouldn't just put the sort of path with github.com/ your GitHub username / the repo and expect it to suddenly pull it in. Or would you? Well, to start with, you wouldn't. Okay, you'd usually use a go get command. And what this will do is it will grab all of those packages or grab it from github.com /gorilla mux, and it will pull it and download it onto your machine. And there you can put it into your Go path that we established last time in the last episode, and it will be able to pull that package into your program. So when you're running your Go command or your Go run, it would then pick it up from your Go path because it would already be in there. It would be able to find it because you'd then be referencing it with the same path. So we kind of looked at, I'll show you in a second how you do this actually. And then the second option is Go mod tidy. Now this is where you would put the package at the top, or you try and use it in your code, and then you'd use Go mod tidy, which is part of the modules toolchain. So this is where I kind of showed it last time. You have to do Go mod init and then Go mod tidy, and it kind of goes off, downloads, pulls in the right version for you, etc. It kind of knows where to go from there. It's quite smart, but that's in VS Code once you have all the plugins added in. So let's have a look at this little path that I was sort of talking about. So here we've got our Go path. In your Go path, you have source, you've got github.com. We've got an example of Go for guides, greet, and then greet.go. So this is just a sort of a folder directory chain here. And inside this greet.go, I'm going to write some code, and I'm going to call it package greet. It's going to have the format import, and it's just going to print out hello world. That's all it's going to do. Capitalize H for the hello, because it needs to be a global function. We'll get onto that later. But all this is going to return is hello world when it's called. And this is where we can use our own packages that we create ourselves and call them elsewhere in our code. So we don't always need to bring in a third party. We don't always need to use a standard library. We can create our own from within our own directory. So if you keep an eye on that directory, there's one thing that's only going to change here, and it's just the bottom two lines where it says greet and greet.go for the next slide. We're going to have example and main.go. So the same folder tree, Go path, source, github.com, Go for guides, but this time we have example, and then we have main.go. Okay, and in main.go, we're going to import our own package. So you can see how that doesn't really look any different to a third-party import at this point, because it's still within the same folder directory, or the same folder tree, github.com/go for guides/greet. Now that just looks like a third-party import to anybody else, but we've actually written it ourselves. And from there, in the main function, we can say greet.hello. And that's going to output at the bottom, hello world. So it's going to call this code. We've imported it into our main file, or our main Go file, package main rather. And then we've called it. And you can put parameters in here. You can pass them through. You can pass them around. But that's fundamentally how you would create your own package for an import. What next? You can aliasing. That's what I'm trying to say. Aliasing. You can alias your own packages, and you can alias other packages. So in here we can see on the left-hand side, we've got import FMT. So we're going to import the format package, and that is correlated at the bottom, fmt.println, just how you print something out to your terminal. And on the right-hand side, we've got import FMT. So you can kind of see we've got an alias now for FMT. Now, you would want to do this if you have a package that is already named the same as a third-party package or a personal package that you've written. And there can create some clashes. To get over that, that's where you'd use an alias. So you can modify the names of packages and their functions within Go and putting an alias there just to help you with your code to stop these clashes, which is pretty cool. Okay, I really like this because it allows you to take really long import names and really shorten them down. And you'll see that quite a lot in Go. You'll see a lot of single letter functions, or not functions, but variables. You'll see a lot of it, and you'll see a lot of aliasing within imports because so many people like to call their packages all the same thing. And you see a lot of versioning too. So version 2, with Fiber, you get version 1, version 2, but it all looks the same and it can get pretty complicated. So aliasing is a really, really good way to avoid all of those. And then you have formatting. So this is quite a cool one because by default, most editors will actually format things for you. You automatically let you configure your editor to do this, or it will use part of Go imports, which is part of the Go toolchain, to do it for you, which is pretty awesome. I quite like this because it stops you having to dig around for all of these different packages and writing them the correct way and putting them in the correct order and making sure that everything is all dandy, because that can be quite time consuming. There's space, different lines in between them and whatnot. But as you can see here on the left hand side, and I apologize if I look over here, I'm looking at the big screen, which is my presentation, which is right next to the camera. But on the left hand side, we've got FMT, and that's how you import a single import into your code. On the right hand side, you can see we've got some third party imports at the bottom, and we've got our standard library imports at the top. And this is multiple imports in one. So you just put some braces around them. As you can see, import, open brace, first party packages, break line, third party packages, or your own written packages with the github.com / etc. That's how you would format your imports. And that's how most editors do. So if you were to install the Go plugin on the marketplace from VS Code, it will do exactly this for you, which is pretty awesome. So you don't have to worry about it. Easy. So let's have a little look at functions. Everything in programming, mostly, is centered around functions, and Go is absolutely no different. So functions are really central in Go. I've kind of mentioned this in the introduction. That is a key pillar at this point. Now, functions are needed, as you can imagine, or methods, functions. They're all needed to perform actions, to perform the actions that you want the code to do, whether it's creating a file or whether it's creating a network request. You need a function to do that, and it's absolutely critical in Go to house them. So this is how you do it. We use functions. Go requires explicit returns, okay? So it won't automatically return the value of the last expression. In some languages it does, but in Go it certainly doesn't. You have to explicitly return values, okay? And we're going to get a little bit deeper into that as we go on, because it's quite fun. When you're using multiple parameters, you can omit the type of the data. So we mentioned in the first episode that Go is strongly typed. So when you're passing variables around, or when you're passing parameters into functions, you need to specify the type. But if you have multiple parameters of the same data type, I don't know, integers, you don't have to write 1 int, 2 int, 3 int, etc. You can just write 1, 2, 3, and then at the end have int, and it will just omit it, and it will assume the previous ones that you've written are also of the same data type. It helps tidy up the code. It helps make it simpler. It's quite fun. It's quite good. And I'll show you that with a code example afterwards. And of course, you would call them how you would expect to call many functions in many languages. Like I said, this is not too dissimilar to Node.js or JavaScript or many other languages. But you'd call it with func and then your arguments, or function and then your arguments, however you want to read that. It's pretty standard across the board. Okay, this is deliberate because it's supposed to be a user-friendly language for you to interact with. And it sure does that. It makes it nice and easy to write functions, return values, and call them. So let's dig a little bit deeper. Okay, so functions. In Go, you can have multiple return values. Built-in de facto support for multiple return values from Go, which is really, really good, but can be really, really complicated sometimes. And we're going to show you how to sort of get around that with a code example afterwards. So each and every one of these slides, whether it's multiple return values, recursion, etc., I've also got a coding example for afterwards. Okay, so what next? So it's denoted with a function signature as func add int. Okay, so I kind of mentioned in the previous slide where you put a parameter in, but now you can have multiple values in. And I actually think I've done that signature maybe a little bit wrong for the wrong slide. It still makes sense because it would just be afterwards, but I'll show you that in a second. What else? You can use both return values from a function call, or you can use one. Okay, so just because your function returns multiple return values doesn't necessarily mean you have to use them, which is really quite interesting because it makes you think, well, why would you return multiple values if you're not going to use all of the values? You could have an error and you could have a result, or you could have an error in a string or something, and it could, throw back lots of things, and you'd want to just maybe omit one and keep the other. It has its perks, but it's also quite confusing. And the way that you do that is by using an underscore, a little bit of a magic underscore. Now, I'm going to show you in the code how to use that, but that's a really, really important part of programming in Go, is this little underscore, because it allows you to remove one of those return values. So if everything comes back, because it's so strongly typed and coupled and sort of quite tight together, it allows you to sort of decouple it and be a little bit more free with your values that you're playing with and the return values of all the functions. And of course, you have global and local functions, much like in other programs. Now, the way to think of this is, I kind of showed you earlier, with a capital H for the hello function. Now, what that does is it allows you to call that function from outside of its current package. So when we were calling that hello function from greet, it was calling it from the main package. It was widely available. If it was a lowercase h, you wouldn't have been able to access that at all. It's scoped, which is quite nice. It helps keep your import your functions, everything quite neat and tidy within certain packages. It allows for clean coding. Variadic functions, the fun ones, right? So this is a way of passing through an unknown number of parameters into a function, okay? Now, you can be, a really good example of this is actually fmt.println, because you can add multiple things into the println function, okay? And it's never going to really know how many, it's not always expecting one or two. You could have a number of values that you're pushing through. And the way you do that is actually by using an ellipsis in Go. It's called 3 dots, and it just tells the compiler that the function will accept anything from no parameters to multiple parameters, as many as you want to stick in, okay? And it will handle it appropriately. And obviously, if you're going to be throwing in the wrong data types and whatnot, it will error out, of course, because it's compiled. But it's a really nice and clean way to say, I don't know how many parameters I'm going to have for this. It could be 5, it could be 2, it could be 10. So you're going to use an ellipsis to denote that. And here's a really good example. So this is an example of the code which I'm going to show you shortly. And a variadic example, and you've got the S, and then you've got ... string. And what that's saying is S can be a number of string values. Doesn't know how many. It could be 1, 2, 3. But it's going to be passing it through, and then it's going to put it into the println statement and print out the values that came through. It could be 0 or it could be 10. Who knows? But that's how you denote it, with a ellipsis. And then you've got anonymous functions. And I've put closures here because anonymous functions are more often than not the ones that cause closures. Now, an anonymous function is a way of not really denoting a function with a name, okay? And a closure is a function that references variables from outside of its body. So you don't have to have local variables. You can have ones which are outside, scoped elsewhere, and be able to call them. Again, I'll show you with code. It's a little bit easier to explain that with code. But it's also known as function literal in Go. You may see that thrown around. You may see it with errors. If you're coding, you may see that in like the output stack. But it's sometimes called a function literal. It can accept arguments. And this is where it gets pretty tricky now, because you can also pass anonymous functions in as an argument into another function. Again, this is like, what do you do at this point? Because this is getting pretty deep, but it's really, really imperative to understand what anonymous functions are and how you can use them. And again, I've got a coding example after to show you. We've got recursion. So Go supports recursive functions. Now, a recursive function is a function that calls itself on the tin. That's basically what it is. And the most common example that you're going to see of this is the Fibonacci sequence. I'm not going to go through the Fibonacci itself, but I do have a little program which will show you exactly what recursion means and a recursive function in play. So, in conclusion, func is the declaration of a function. Functions need a good name because just standard programming practice. Parameters, they're a value that you pass into a function. And again, they're optional. You can have many parameters, you can have many return values, or you can have none. And I kind of already taken away from the next bullet point, where a return type, a function may return a value. And I put that in capitals because it doesn't always return a value. And then, of course, in the function body is a collection of statements that define what a function does, whether that is calling a HTTP endpoint, whether it's printing a line to terminal. Now, testing, because I realize I've been speaking for half an hour and I want to zoom through this and actually have some time to show you some good code examples. So testing, okay? How should we test? Now, you're going to see a number of people say a number of different things in many different ways. This is how I believe we should test. So this is my personal opinion, okay? And I believe we should use test-driven development. And I'm going to show you this shortly. So test-driven development, what is it? That's when you write a test or you write your test code and it fails, okay? You expect nothing to pass. You then run enough code to pass that test. That's why it's an amber, because the test passes, but you may have written the most ugly, most worst, inefficient code you've ever written in your life to get it working, but it works. It passes that test. And then you refactor your code, okay? So then you look back and think, well, actually, this can be done if we break it out into a separate function, or, this function does many, many things. We only want it to do one or two things well. So you start breaking them out and refactoring your code to have better names, to include better variables. You might tidy it up to prevent memory leaks. But that's the whole point of refactoring your code. You want it to be neat. You want to just write enough code to pass the test. You don't want to start writing any extra code. What's it called? There's a name for it. Scope creep. I was notorious for scope creep when I was an engineer, because I'd always think, oh, you know what? Maybe someone might want to add this into their API later, or maybe I'll give them an extra return value because it might be useful later. Nope, you just write enough code, pass that test, and then you refactor it and be super efficient. It also helps your CI/CD builds, because then you don't have any arbitrary code lying around, and then it's quicker, and then you can get from code to production faster. It's that whole efficiency wheel of oiling the machine for developers. So we also have some elements to testing in Go. You have got the standard built-in library for testing. It is built for developer-friendly engagement. So there is an import called testing. Aptly enough, it's pretty well named. But of course, that's not all, because as developers, we always like to add extra things. We always like to have that a little bit more. And there are, of course, third-party imports that you can bring in as well. And this one is assert. So Testify Assert is a really, really popular testing library. It allows you to do assertion. So if you've ever worked with Node, if you've ever worked with Mocha or Chai, I believe that's the testing frameworks, or Cypress for React front ends, you can use assertions. Very, very similar. In fact, it's exactly the same, just written slightly differently in Go. Test files in Go are denoted with the file name _test.go. So you have the parent file name, which could be, ABC _test, and that'll be your test file for ABC. Got a great example here, which I'm going to show you later. So we can see math.go, and then we've got math _test.go. Now the test files are usually within the same directory as the parent file. It's not within all realms to do that, because people like to break out their tests into test suites and have them run separately and be all over the place. But for a small project like the ones which I build, I like to specifically have them in the same directory. It allows me to run some certain commands to hit them every time and understand where all of my codes really sat within my projects. It's not bad practice. It's not, you can break them out. They don't have to be in the same directory. It's just how I personally do this one. You've got unit testing. Everybody loves unit testing, and it's pretty easy to do in Go. I say easy. I'm going to show you how simple. I don't like the word easy. Simple. It's more simple to do it with Go. And of course, you just write the command go test, and it will run any test files within the current directory that you're working within, and it will run the test files and give you an output. And of course, you can have some other added on CLI bits like -v for verbose and give you bit more output if you want. That's a pretty cool way to do this. And of course, Go supports unit testing. You have coverage testing. This is my favorite one, and I'm going to show you why shortly. But you can have a look at your cover profile, and it will spit it out into a file in your current directory, and it will also allow you to view it in a web browser, which is pretty cool. And it's really, really cool in CI/CD pipelines, because you can get like a whole output as you're running through, and you get some really cool plugins in GitHub which allow you to sort of see graphs and all sorts of fun things. But cover profile, of course, you get this with many other languages, but this is just totally built into the toolchain already. And the final one is benchmarking. Benchmarking is really, really important, because if you want to write some good code, if you want to write some efficient code, you want to know how it performs on your machine, or how it's currently performing on your machine. And this can be really important when it comes to running your code remotely, whether it's in a remote virtual desktop, whether it's in a container, whether it is in a CI/CD pipeline. You want to see how it's performing on each individual machine, because Go is cross-compiled. Okay, you can write Go binaries for many different architectures and operating systems. So you can benchmark. Really, really cool. And again, I'm going to show you how to do that in a second. So let's code. Let's code. Let me jump out of here, have a sip of water, and answer any questions that we have. Do we have any questions in chat? Okay, let me just stop sharing. Okay, so hello, Peter. How are you doing? So you are from Dartmoor in the UK. Nice. And we've got Unix Dev from Long Island. Hello, nice to see you. Cool. So I'm actually going to go ahead and share my screen again. And what I'm going to do is I'm going to start running through some functions. So I'm going to share this screen, which is my web browser. Now, hopefully, if I zoom in a little bit, what we're going to look at is, this is Go Playground, okay? Now, in Go Playground, this, I kind of showed you in the first episode, but it allows you to write Go code and test it in your, well, if you have any bugs or something locally that you can't debug, this is a really good abstraction or a really good way to write your code in an editor, in a browser, made directly from the Go team. So what have we got here? We've got two functions. So function number 1 plus, and then we've got function number 2 plus plus. Now, if we look at the import, we've got format. And plus is going to take in an integer. We can see it here. And it's going to take in another integer, which is over here. So we've got integer A and integer B. And it's going to return an integer. And this is what I forgot to put in my slide, was like the extra return value is going to be int. And this is where you'd have like multiple values or multiple data types at the end of the function signature to denote a double or multiple return value. And what it's going to do is return A plus B. Pretty simple, right? So we look down on our main function, which is, by the way, the main function is the very first function which should be called within a Go program. When you sort of jump into it, you are looking for the main function. The res, which is response, is going to be equal to, and we know that because it is colon and equals, plus 1 and 2. So everybody with me? 1 plus 2 equals 3. That's what we're going to be expecting to see from this print line statement here. Okay, because it's going to go off and call this function, func plus, and it's going to add them and return them. Then the next line down, again, plus plus. Okay, aptly named, nicely, I know. We've got 1, 2, and 3. So we're going to expect to see 6 at the end of this one. But if we look at the function signature, plus plus is actually doing A, B, C, int. That is all. That was what I was saying when you can omit the data type in the function signature right from the beginning. And then it's going to return the final integer, which in this case should be 6. So what I'm going to do is I'm going to go and click run. And if we look at the bottom, we can see here the output 3 and 6. Okay, so that's a really, really nice way of sort of splitting up your functions and seeing how you can sort of massage the function signature at the very beginning to then sort of get your output that you need. And it's just a neater way of coding. I really like this. It can be quite confusing if you're new to Go. It is kind of personal preference. If you really want to be explicit, you can write, A int, B int, but I like to use the shorthand with omitting the data types when they're all the same. So I've got another one over here. So by the way, like I said, as I was going through the slides, I've got all these different functions or different kind of functions that Go supports. And I've got an example for each one of them. So this is the multiple return values function. Okay, so we've got func vals, so values. And it's going to take in no parameters. We're not going to have 0 parameters. We're not going to call it with anything. We're just going to expect something to come back. And like I said, you can have a double return value. So in this instance, we have an int and an int. We've got 3 and 7. So when we call it with our main function, we're calling A and B is equal to, with the colon and the equal sign, vals. So everybody with me? What do we expect this one to be? We expect A and B to return 3 and 7 respectively. Now this is the fun bit. This is a little magic underscore that I was talking about, where we have got the underscore and C. Now we notice that vals returns 2 values, 3 and 7, but we're only going to be taking the second one because the first one we're completely disregarding with an underscore. Okay, so what do we expect C to be? We expect C to be 7. So if I go ahead and run this, we'll see at the bottom 3, 7, 7 as expected. So you can kind of see how we can build this up now by omitting values, by removing return values of what we don't want, what we expect. So it's a really good way to understand how functions are working. Then we got variadic functions. I hope I say that correctly, but these are a little bit more tricky. Okay, so variadic functions is where we are using the ellipsis to denote that we don't know how many parameters we're going to pass through into the function. Okay, so we've got our main function here. So we've got main, and we're going to be calling the variadic example with no parameters. We are going to be calling it with red, blue, and green, red, blue, green, and yellow. As you can see, I'm adding 2, 3, 4 parameters, and it's still not going to change what I'm passing into the function itself. So on the function, we've got the 3 dots. So we have S, which is the data type, which is red, blue. It's a string. And then we're telling it it's a string, but we're also saying with the ellipsis, we don't know how many we're going to pass in. And that's the best bit, because it allows us to sort of really condense our function signature down. Otherwise, we're sort of tied to always having 3 inputs or 4 inputs or 5. How do you make that a little bit more dynamic? Okay, it's harder. So we use this. And I'm just going to be muting I'm going to put myself on focus because I'm just getting pinged nonstop in my ear. So what are we going to get with this one then? How is this going to display itself to us? Well, if we run it, I will show you. So we can see an empty brackets. We're seeing red and blue. We're seeing red, blue, and green. We're seeing red, blue, green, and yellow. So with every time we're calling this function, we're calling it with a string, but we're also telling it, we don't know how many I'm going to pass through, but you better print out however many I want to pass in. And like I said, this is a fantastic example of a variadic function itself being println or println with the FMT package, because we only just passed S for string. That's all we passed in. So a really, really powerful function to be using in Go. What else do we have? Okay, this one is a little bit more verbose, but we're going to look at some closures here. Okay, now this is a main package. Don't be scared, because I'm just going to be really quite blunt with this one. So we're going to be calling, so we look at the main function to start with, and we call next int, and we're going to equal that to int sequence. Okay, int sequence is this function up here. But hey, look, straight after that, we have another function with another return value. We're calling an inline function. Okay. Now within this function here, we're specifying that I is equal to 0. And then we have another function that we're going to be returning. Okay, so on the return value, it gets pretty complicated, but this is where we have a closure, because inside here, we're saying I++, which is pretty standard across the board, where you're just iterating over a counter, and then we're going to return it every time we're calling it. So it's a really verbose way of just having a loop in some weird sense. But if we call it down here, we call it several times. Okay. So every time we call it the first time, it's just going to increment a counter, call it again, increment a counter, call it again, increment a counter. Okay. And we do that up to this third point. And then we say new int is equal to int sequence. A little bit more complicated now, because we're resetting that counter. Okay. So it's going to go, I think, maybe 0, 1, 2, 3, or maybe 0, 1, 2. But then the final one is going to reset the counter again. So if we run that, we can see that we have 1. Okay, it started from 1, 1, 2, 3, and then a 1, because it reset at the end. Okay, the closure has its own distinct state at that point. Okay, and the closure's up in here. Inline functions. Really, really cool. Really, really complicated. It took me a long time to get my head around these as a developer. So I'm not expecting you all to take away and know all of this straight off the bat. But as we get through the series, I'm going to be using these kind of functions in the programs that I'm writing for you and trying to explain them in a way that is easier to understand, because it can all just look like a load of gobbledygook to a lot of people, especially it did for me when I started coding in Go, and really not understanding how to use this effectively, because there's a time and a place you'd use this. And like I said, it kind of denotes maybe a bit of a loop at this point, but it's quite a safe one to do. And then finally, we have recursion. Now, I'm not going to go through this entire recursive function for you because it just doesn't need to be done. It's Fibonacci. This is a really standard example that you can find anywhere. But what I really want to pull from this is the recursive fact that it calls itself. And it calls itself from within itself. Okay, so ignore the main for a minute. In this fact n int signature, which is just a factual, you're taking a parameter of n, it's going to be an integer, and it's going to return an integer. Okay, and inside this function, we're going to say if n is equal to 0, then return 1, right? That's an out state. Okay, otherwise, return n times fact of n minus 1. So every time we're going to pass in 7. So down here, we're going to pass in 7, fact of 7. And every time it loops around, it's going to count down to 0. Well, that's at the point you want it to break out. Okay, so it's calling itself from within itself. That's a recursive function. That's all I need you to take away from this. Go supports recursion, which is really, really powerful. And if I run this, you'll see some big Fibonacci number at the bottom, if it wants to display. Yep, there we go. 5,040 and 13 lines. That's all it is. Okay, but it's just recursive. And again, you can have closures, but it needs to be noted with a variable. Again, that's a little bit too over our head at this point. But again, I've stated here, closures can also be recursive, but this requires a closure to be declared with a typed variable explicitly before it's defined. And what I mean by that is we've got var, fib, and then we're calling a function, an inline function at this point, with a return value of an integer. That's what I'm doing there. I can make all of these available. I can share all of these links with you, so you can have a little play with them yourself if you wish. And in fact, I would start dropping some links into the chat at this point. So let me just jump out and grab some links up on my other screen. We have got, so if you want to take part in the career, or the career upskilling, this is this one. And if you want to have a go at the Cloud Skills Challenge, before I move on to testing, because we have got 10 minutes left and that's perfectly on time. That's my Cloud Skills Challenge. And then if you want to check out the very first episode of this stream series, then you can check out this link. And if you want to have a little look at some of the functions, so I have stupidly not grouped them together in my notes. I hope that worked. So that's the first one. And here's the second one. I'm just dumping the channel with links. I am so sorry. And if you're watching on Twitter, hello. You won't be able to see these, but if you go to YouTube, you will be able to see the chat. And this is a really good way for you to start playing with some functions in Go and have a little go at them. And I'll post in 2 more links and then we'll crack on with testing because that's the fun bit. And I didn't actually create a link for that 5th one. So here we go. Let's do share and drop you in there. There we go. Some lovely links for you for the playground. So if you click on them, you can take yourself to Go Playground and you can have a little play with them yourself. So we don't need that one anymore. What we do need now is some code. Okay, so last week we created, or I created for you, a little function that said, hello, Gophers. Really, really boring. Okay. Within the same package, I've also got a math function. Okay. Now this math function over here, we've got add and subtract. Okay. And this add is taking in X, Y as an integer. We've got the result is an integer. So again, you can denote them with a variable name. And it's just going to return X and Y. So X plus Y rather. And then again, subtract, same again, but X minus Y. How do we test this function? How do we test this functionality? So within Go, Really, really cool. Let's create a test file. So we've got math_test.go in the same directory as the math file. So let's have a little look at a function or a testable function. Okay. So let me just grab up my notes to make sure I do this in the correct order, because I've done this a million times, but trust me, when you're on a stream, it's a different kettle of fish. Cool. So let's save that file. Okay. Now let me go into this directory. Let me go to package and cd math. And then I can just do go test. What it's going to do is it should just run a test suite saying, ta-da, okay, it passed. Because what I'm doing is I'm saying I got, or the got and want, okay, what you're giving it, so 4 and 6, and you want it to return 10, okay? And when you're testing a function, you always put test at the beginning with a capital T. And then in the brackets, you'll always put T with a star testing.t, and that's just a pointer to the testing package within Go itself, okay? We're going to touch on that with pointers in the final episode, but this is a really, really good place to start. So we say 4 plus 6 is 10, okay? And if the got isn't what we wanted, so if we got something other than 10, it would throw an error. And if we had, I don't know, let's just say that is 11, and this totally off plan now. But if we do test, we can see that it fails, and you can see where. Okay, so it's saying we got 11, but we wanted something else. It's just not, okay, that didn't display properly, but it's not what we wanted. Okay, so it errored, and we know it errored, so that's a problem. So let's put that one back to 10. Okay, so let's comment that one out. And if you are stuck on stream, if you want to zoom in, if that's not very clear, let me zoom in a little bit. So hopefully that is well, that's a bit too big for me to read. There we go. So now we're going to move on to some table tests. Okay. So table tests are quite fun because this allows us to do many tests in one go. Okay, so let me just get rid of that test. We don't want that function anymore. But what we do want is this one here. Okay, and we can comment the benchmark out as well. Don't need that. What we got here is we've got a struct of argument 1 and argument 2 and the expected. Okay, so this struct just denotes this data type here, which is 2, 3, 5. Okay, so same principle. We're going to be testing it. Same function, test add. So the add function. And what we're going to say is we're saying argument 1 is 2 plus argument 3. No, I said that wrong. Argument 1, which is 2, argument 2, which is 3, and we're expecting that to equal 5. Okay, so 2 plus 3 is 5, 4 plus 8 is 12, 6 plus 9 is 15, and 3 plus 10 is 13. Okay, that's what we're expecting when we run a test suite. And again, it's just going to do the same, but this time we've got a for and a range loop. Okay, so a range loop is kind of like a for loop, just with a little bit of difference. I will explain this in a later stream. We don't have time now. But essentially saying the same thing, saying if it's not what we expected, throw an error. Okay, if one of the arguments doesn't pass, bottom out. Okay, so if we clear this terminal now and we run, let's do go run -v for a verbose output. Okay, that is not what I wanted to do. Let's clear that one. Go test -v. That's the right one. You can see a little bit more of a verbose output. Okay, it's saying ran test add, and you can have multiple tests at this point. So inside this function, you can have multiple testing outputs, and it passed. And it passed pretty quickly. It's probably cached. Okay. So now we've got the test running, and that's working. Let's have a look at a coverage profile. Okay, we're not going to touch benchmarking just yet. We're going to look at a coverage. So let me just grab a line of code or a command from my notes. And what this is go test hyphen cover profile equals coverage.out. Now, if you keep an eye on the left-hand panel, you'll see a coverage.out file appear in my directory when I run this. Now you can see 50% of the statements are covered by tests. Now we know that because we haven't written any tests for the subtract yet. We haven't done test subtract. We don't actually have time to write a subtract file function, but similar process. You just copy and paste the same code. You can have multiple subtraction statements in a table test, which is really, really cool. Now, if this wasn't good enough, We can also see this in a browser window. Now, this is going to be fun because this is a really, really neat way to see your tests. So if we look at this coverage test, we can just see a load of stuff like the packages that it tested. So if I want to see it in a web browser, I do go tool cover, so it's part of the go tool chain, hyphen HTML equals coverage dot out. And it opened up in the wrong window, but over here we can see that it opened up in a browser window, and it's telling me exactly what was tested and what was not. So the ones that are tested in green and the ones red were not. And we can see not covered and covered and not tracked. And we can see up here it's 50%, and we can switch between different packages if we're testing multiple packages at the same time, which is pretty neat. It's a really cool way to see your test coverage in Go. By the way, if you have any questions, please throw them in the chat. Let me know. Ask away. So let's close that one. Now, I think we could probably move on to benchmarking. And this is fun, okay, because you can be really explicit with this or not, as it may be. So we've got a benchmark test down here, which is going to benchmark our function. And it's saying benchmark add. So we're same as what we did with test. So test add, benchmark add. But this time we're going to be called B with the pointer to testing.b. So it's a different part of the testing package now that we're going to be grabbing, okay? So that's just what that does. And inside here, we've got a for loop, which iterates over b.n. So the amount of times that we're going over this, or you specify, and we're just going to add 4 and 6 together. Now, that's just going to equal 10, but we want to know how quickly it can do that. Okay, so we're just going to do go test hyphen benchmark equals dot. Now that dot is pretty standard across the board. Any file within the directory you're in, it'll run a benchmark test if there is one. And that's it. Pretty simple, right? It didn't give you much information. But if we do go test bench add and be a little bit more explicit, hopefully this will give us a little bit more information, and it doesn't want to. That's because we didn't even save the file. Try again. There we go. That's the output I wanted. Okay. And it's telling me on the Darwin system with the architecture of ARM64, I'm running the new chip, the M1 Mac, in the package maths, and we've got a benchmark. It's expected 10, which is the answer. It did that in 0.3, basically 0.3 nanoseconds per operation, which is pretty cool, pretty quick. And you can do this throughout different systems. Again, virtual machines, CI/CD pipelines. Do you need beefier machines when you're doing your testing suite, etc.? So again, a really, really good way to benchmark your functions. And we can go way into depth of this if you really want me to on like a later episode. I can go like really deep dive into benchmarking. It's something which I've done many years. I really, really like digging into like the semantics of a language and how it really performs at a system level. So I'm more than happy if you want that, then throw it in the chat and we can do that one. And the final thing which I'm going to show is the example. Okay, so when it comes to running your Go code, there's no point having great code if you haven't got great documentation. So this is a really good way to show in your testing file, you can write documentation. Okay, so documenting with examples. Again, this is a really good way to show that. So what we do example add, and then we're just going to write add 4 and 6 together. So we're just going to call the function add, which is just adding the two functions together, and it's just going to throw it out. So if I wanted to do that, all I'd have to do is go test, and you can see it down here. It ran this as a test, but it also ran an example at the bottom. So again, documenting is a really, really powerful way to make your project stand out. And all of this within a test file. Now, I did say I'm going to write a HTTP function for you, and I'm not lying. I'm going to do it in a couple of seconds, because I wanted to write from scratch for you, but I do actually have it copy and pasted in case we ran out of time. But I want to show you what to do. I'm going to walk you through the code as well. So let me just grab this one. Let me grab this code. Let me remove that. Let's clear this so it doesn't get confusing for you. We paste in this function, okay? So we're just going to replace the main.go file with a HTTP server. Now, there's a lot of comments in here, so I'm going to run through it, okay? So we've got package main, same as before. We've got some imports. We've got the format, we got the net HTTP, and we got string conversion. Okay, string conversion, because I'm going to show you something in a second with what I'm doing with that one. And then I'm pulling in my own package. I'm pulling in the own package I created for the math package. I'm going to pull in some numbers. I want it to return a sum for me. So in the main function, I've got a handler, which is my home root of /. I've got a print line saying the server started on port 8080, because that's what I'm running locally. And I've got a listen and serve function. And this is going to spin it up on port 8080 for me. And the nil just depicts a nil value for return. So I'm passing in, sorry. I don't need to pass anything in at that point. And that's what I need to start a server. Now I've got a home function as well. And the home function is where I'm using the string conversion. And instead of having a message in a string format, I'm going to actually call my function that I created earlier, my sum function. So 2 plus 4. And what I'm going to do, I'm going to add 2 and 4 together, and I'm going to print it out. And it's going to tell me what it is, okay? So the sum of your numbers is the message that I'm going to print out. Sounds pretty simple? Sound okay? Let's do it. So let's save this file. And then let's do, I don't know, somewhere. I don't know why it's saying I've got a problem somewhere, but alas, we'll run with this one. Let's go back. Let's get out of that directory. And where are we? Oh, so we're in the main.go. So let's do go run main.go. And hopefully it'll print out something saying started on port 8080. Now let me go and grab my browser over here, and let's do localhost 8080. The sum of your number is 6. Okay. What does that prove? Now that proves that the functional package that I created earlier with the math package is able to be called from within my own server. So I've imported my own code, which did something elsewhere. Okay, so that's HTTP server. Now, what's next? Let me just quickly get up my slides again. And where are we? We're over here. Oh, I don't know why I stopped sharing my screen. I should have kept that one on there. Sorry, everybody. There we go. Share this one again. Throw you back on the stream. Cool. What's next? So 30th November, because next week I'm at a conference talk. I'm going to be running episode number 3. Now, episode number 3, we're going to be working on structs. We're going to be working on JSON and some other data types. So that's the real fun stuff, because that's when we start getting lots of different data moving around. And that's the purpose of the HTTP web server that I just created. Okay, so the basis of a project. So we're going to be playing with those in 2 weeks' time. So I look forward to seeing you there. And of course, a massive thank you for coming today. It is brilliant. I love creating lots of fun and interactive material for you all to play with. And please scan that QR code or go to link aka.ms/learngo-with-Liam-CSC for my Cloud Skills Challenge. And I look forward to any questions that we may have. So I'm going to dig open StreamYard. Do we have any questions? Let me skim through. Oh, it's a little less lively today. What have we got? I'm interested in running a benchmark with Go routine. Okay, let me just add up this one. So what I mean is, see the concurrency in Go, using Go routines versus not using Go routines. Really good question. You are pipping me to the post, because the 4th episode in the series is all about memory management with Go routines and channels and interrupts that we're going to be talking through, and some great examples there. So you can use benchmarking with Go routines, because Go routines are kind of like they're running on a sort of imaginary thread. Okay, it's not like an actual thread on your CPU. And the way that you can sort of manage this is by using channels to move data across from one another. Now you can benchmark them, and it can go, you can really, really benchmark them. That's the purpose of them. Okay, but we're going to get into a little bit of that in episode number 4. Do we have any other questions from anybody online still? No? I'm going to probably close the stream off now then. So thank you very much for coming along. It's been a pleasure as always. If you have any questions, please do reach out on social media. So my Twitter handle is down here somewhere, at Liam C. Hampton, and I will answer any questions that you have. My DMs are always open. Please do let me know what you get up to, and if you have any questions, or just poke around. So I hope you enjoyed this one. Thank you ever so much for coming, and I will see you in 2 weeks' time. Bye now.